Hello, my name is Adeyemi for Clueless Junkie. In this video, I'll be showing you how to calculate the cost and quantity of reinforcements needed for a new house project. This video is in two parts. The first part is about the needed reinforcement for the foundation of a house, from the column footing meshes to column starter rebars, footing rebars, ground floor beams, and all that. If you're interested in the first part, I'll post a link in the description and comment section below. Do well to check that out. This part is going to be about the superstructure of a new house. This part will cover the column extension rebars, the first floor beams, staircase rebars, and slab rebars. If you're new to this channel, do well to subscribe, like this video, and join. I'll be happy to have you as a member of this channel. Thank you. So let's get on with it. In the substructural calculation, the staircase starter rebars was not included, so I'm going to rush over that before moving on to the calculation for the reinforcement for the superstructural part. So for the staircase starter rebar, a typical staircase rebar looks as such. We are going to take the values of the individual rebar and then add that up. In this instance, I'm getting 2 meters for each bar, and there is about 7 units of that 2 meters. So we'll multiply 7 by 2, and that gives 14 meters. That's a little over 12 meter rod. So on the list we created at the beginning, we're going to specify one length of Y12 iron, and then use one offcut from item 3, that's footing rebars, to supplement that. And then for the distribution bar for the staircase starter rebars, I need to get the length of each one, and what I have is about 1.175 meter, and there's 10 units of that, so multiply that, gives almost 12 meter. That's one length of 12 meter rod. And on the list we'll specify 1 under the type of rod it is. So that's 1 Y10 iron for the distribution bar. We'll move on to the superstructure. On the superstructure, we'll cover the column extension rebars, the first floor beams, staircase rebars, and finally the slab rebars. So we're going to create a new list for the superstructure, and on the description we'll put the first item, which is the column extension rebars. For the column extension rebars, the details of these bars will be stated clearly in the structural drawing, and for this floor plan I go here, the unit length of the column rebars is about 4 meter, and we know that the average length of a steel rod is 12 meter. So if we were to divide 12 meter by 4 meter, we're getting 3 units of 4 meter rebar from an average length of the rod. So if one column needs 4 units of 4 meter rods, so 4 similar columns will require 16 units of 4 meter rods. So we'll divide 16 by 3, and that's 5.33. We can invariably say we'll be needing 6 units for that. So on the list we'll specify 6 units under the type of rod. And then for the column ties, we need to know what the length of each tie, and then from the section view of the tie we can deduce the size, and then we'll add all that together with hook, and that gives 800 millimeters. So how many ties are there on each column? So we have 15 ties for each column, and there are 4 columns, so we'll do 15 multiplied by 4, that's 60, and then 12 meter divided by 0.8 is 15 pieces of ties from one length of iron. So if we do 60 divide by 15 pieces, that's 4 lengths of 12 meter rod. Go to the list and specify that under the type of reinforcement. The next item is the first floor beams. The details of these beams are usually stated under the beams details in the structural drawings. So on the first floor beams, we need to do the beam main bars, and then that's we get the length of each bar in the beams details, and then add that together with anchorage at each ends, and I'm having 5.23 meter for each beam here. And then from the section view, there's about 7 bars in each beam, and there are 4 beams, so 4 multiplied by 7 equals 28, so we need 28 units of 5.23 meter bar. One length of 12 meter rod will give 2 units of 5.23 meter. So 14 lengths of 12 meter rod will be needed to get 28 units of 5.23 meters. So we can go to the list and specify 14 lengths of Y16 for the beams bars. There's going to be 1.54 meter of cuts left after that is done. So the length of what is the length of each stirrup for the beam? From the drawings we have, we can take the values and add those up, and that gives 1.2 meter. And how many stirrups for each beam? There are about 24 stirrups for each beam, and there are 4 beams, so 24 multiplied by 4, that's 96 stirrups. So how many lengths of 12 meter rod will be needed for 96 stirrups? We divide 12 meter by 1.2, and that gives 10 pieces. So we'll do 96 divided by 10, so that's about 9.6 length of 12 meter rod. So that's 9 12 meter rods and off cuts. So we're going to put that 9 on the type of, and then we use off cuts from item 2 there to supplement that. So we use 7.2 meter whiten off cut from the second item in the substructural part to supplement that. The next item is the staircase rebars. And for the staircase rebar, we're going to do the main bars and the distribution bars. Firstly, we'll start with the first flight. It looks typical like this, flight 1. For the flight 2, we'll do that separately, and we'll do for the intermediate landing as well. So for the first flight, a bar bending schedule for the staircase rebar will detail the specific length and the type of rebar, and the bending details for the main bars. So moving on, the main bars, the details and the dimensions for the rebars are added, and if we add those up, it gives us the length for that main bar. So add these values up, and in this instance I'm getting 7.182 meter for one of that. How many bars in the first flight? We have about 7. So 7 lengths of 12 meter rod with a 4.81 off cuts. We do for the additional rebar, and then that's 600 millimeters and plus 600 millimeters. That's about 1.2 meter. We use 2 off cuts from above, that's from the 4.818. Then we'll do the distribution bars. How many distribution bars are on the first flight? And each distribution bar is about 1.175 meter, and there are 24 units in the first flight. We'll do 24 multiplied by 1.175, and that gives 28.2 meter. If we divide it 28.2 by 12 meter average rod length, to invariably give us 2 lengths of 12 meter iron. We'll move on and do for the intermediate landing. The distribution bar is about 2.4 meter going from the floor plan. We'll specify that distribution bar 2.4 meter. How many units of that? There's about 10 units of those on the intermediate landing. So the 2.4 multiplied by 10, that gives 24 meter. 24 meter divided by 12 meter average rod length, and that's about 2 lengths of 12 meter rods for the intermediate landing. The next thing, we'll move on to the second flight. These details are to be found in the bar bending schedule. So if we break those apart, we've got three main bars to extrapolate. We'll take the main bar for the second flight and then get the details from the bar bending schedule for the staircase rebar. Now add these specific values specifying the bending details and all. Then add those values up, and that gives 7.93 meter for the main bar in the second flight. What's the number of main bars in the flight? There's about 7 of it, and that invariably means we need 7 lengths of 12 meter rods. It's going to be about 4.07 meter offcuts. So moving on to the other bar, is also a main bar. Adding those values up, we would get 2.452 meter, 7 units. We use offcut from first flight main bars, and then the additional rebar, this one down there, has 600 millimeter plus 600 millimeter. That's 1.2 meter, and there is 7 of that, 7 units. We use offcuts from above. Moving on to the distribution bars for the second flight. The number of distribution bars in the second flight is roughly 29 units. If we multiply 29 by 1.175, that gives 4.075 meter. Divide that by 12 meter, that gives roughly 3 lengths of 12 meter rods. Then we'll move on to the rebar chair. We add the values of that. These details are actually gotten from the bar bending schedule. To add these values up, that's 2.495 for each rebar, for each chair, and then 6 of them, that gives 14.97 meter. Divide 14.97 by 12 meter, which is average length of rod, and that gives roughly 2 lengths of iron. We'll collate that. First flight main bars is about 7 lengths of iron, so we'll specify that on the list. Then the Y10, which is the distribution bars, we'll put 2 lengths there. We'll have offcuts, white of offcuts in that. For the intermediate landing, there's about 2 lengths of Y10 or whichever type of rebar is being used. You specify that under it. And then the second flight, we've got 7 lengths of 12 meter rods, and we'll go to the list and we'll specify 7. And then for the distribution bar, it's about 3 lengths we put there, and then for the remark, we'll specify the offcuts remaining. Then the rebar chairs is roughly 2 lengths of 12 meter iron, so we'll specify that also on the list. So we'll put 2 there. So if we were to add these values, the number of white of iron needed is 14, and then for the Y10 iron, we need 9 lengths of that, and then the offcuts will also be specified, 4.07 meter offcuts, about 4 units of that. So next, we move on to the slab rebars. And for the slab rebars, the point here is to create mesh for the areas that have a floor. This part, we're going to do main bars, which looks about 8 meter for each length of the main rebars. So we'll specify 8 meter for the main bars, and there is about 11 units of that. So we need 11 length of 12 meter rods, and there's going to be about 11 of 4 meter offcuts from that. And then for the other side, that is about 4.196 meter. We'll be needing 6 units of that. So 3 lengths of 12 meter rod should suffice for that. And then for the distribution bars, which are the horizontal ones that go on top of the main bars, and that individual length of that is about 8 meter, and we'll specify that. And then the number of that distribution bar in that region is 5 units. So we need 5 length of 12 meter rods, and we'll get 4 meter offcuts, 5 of that. So on the remainder there, we have distribution bars of 4 meter length. And remember the offcuts we've been having from the other main bars up there. We need 17 units of that. Use offcuts from above. We use 4 meter offcuts from above, and if it's not enough, we complete that offcuts from the staircase rebars. So the main bars top mesh, to complete the top mesh of this region, that 2 meter bars, there's about 6 of that. So we'll do 2 meter multiplied by 6, that's 12 meter rod. So 1 length of 12 meter rod will suffice for that to complete the top mesh of that area. So the next one, to complete the top mesh of that, we need 0.9 meter bars, and there's 5 units of that. So 0.9 meter multiplied by 5, that's 4.5 meter. So finally, for this underside, we'll be needing a 2.04 meter bar to complete the top mesh of that region. So we'll do 2.04 multiplied by 5, so that's 10.2 meter. If we add 4.5 meter to 10.2 meter, that gives 14.7 meter. And if we divide 14.7 meter by an average rod length, that gives 1.225 units. So that's roughly 3 lengths of 12 meter rod to complete the top mesh. If you wonder why this area was introduced, is to provide a sort of a starter for the next flight of staircase if there be another staircase leading to the other floor. So for the slab rebar, the white 12 iron that will be needed is 11 plus 3 plus that. So we'll add those values up and then specify it on the main list. For the white 12 iron, we'll be needing 19 lengths, and then for the white 10, 3 lengths. Then specify the offcuts available on ground, so we can reference that for other parts of reinforcement needed. So if you've come this far, I hope you got something meaningful from this. If it's a bit confusing, you might need to slow it down a little to catch up, and then sum that up, and that gives an estimated range of reinforcements that will be needed for construction. So thank you for watching. I hope you found this video useful and you learned a thing or two. Please subscribe, and do not hesitate to leave a comment, leave a like, and join if possible. I'll be happy to have you as a member of this channel. Catch you on the next one. Stay safe.